Hello everyone and welcome. And today we have two identical fish tanks that are filled with water to the same level. However, one tank contains seawater and the other contains fresh water. And in this problem, we are to find or determine which fish in one of these two tanks will experience the greatest pressure. We know that for a liquid, the pressure increases with the depth of the liquid. So we can express the pressure as a function of the depth of the liquid as pressure is equal to the density of the liquid, the acceleration of free fall, and then the depth. So this equation here gives us the general case where the pressure depends on the depth inside the fluid. So the deeper down the liquid you are, the greater the pressure you experience. However, in this puzzle, we have two tanks with one filled with seawater and the other filled with fresh water. In the one with seawater, we do have two fish, that is fish A and fish B. And the one with the fresh water, we have fish C and fish D. Now we need to eliminate some of these options because we only need to find one option that experiences the greatest pressure. And to eliminate some of these options, we have to look at the two fish in each tank respectively. So for the first tank, that is the tank with the seawater, we have option A, which is at the greatest depth, right? So option A is deeper in the seawater. In that case, if we go by the pressure as a function of the seawater depth, then option A is going to be the one experiencing the greatest pressure, because from the surface of this water all the way to the bottom at point A, we can see it has the greatest depth compared to option B, which just has the depth all the way from the surface to this point. And then for option A is from the surface all the way to this point. So this HA is greater than HB. Therefore, we can say option B is out of this problem, okay? And this is because the density is just the density of seawater. Now let's look at the other tank with the fresh water. We have a similar problem because C is at the same depth as A, whilst option D is at the same depth as option B. And for the fresh water, that is water at a particular density, the one that is deep inside the tank is going to experience the greatest pressure. In that case, we can see option D from the surface of this fluid just has this depth, and then option C is this deep inside the water. So in that case, again, we have option D ruled out of this because option C in the fresh water experiences the greatest pressure. All right, now we have eliminated two options and we are left with two options. That is options A and then C. Now between these two, which are also at the same depth inside their respective tanks, right? However, we can see that now since the depth H is the same for both fish, we need to consider the densities of the water, all right? So to do this, we have to develop two equations for each of these tanks. So for the seawater, the pressure at that depth, okay? So pressure in the seawater at that depth is going to be the density of the seawater times the acceleration of free fall times the height. So let's call this as equation number 1. All right. In the same sense for the fresh water, the pressure for the fresh water is going to be the density of the fresh water times the acceleration of free fall g times the height or the depth. Now, we can divide equation 1 by equation 2. So we are dividing these two equations. We can see since the depths are the same, they are going to cancel out. since the acceleration of free fall are the same, they are also going to cancel out. And then we are left with the ratio of the pressure at a depth inside the seawater to the pressure at a depth inside the fresh water. So we are left with pressure in the seawater divided by the pressure in the fresh water is equal to the ratio of their respective densities. So the density of the seawater divided by the density of the fresh water. Now, for this case, we know that the density of seawater is greater than the density for fresh water. All right. So with that, we can see that the pressure experienced by fish in the seawater is going to be equal to the ratio, which is the density of the seawater divided by the density of the fresh water, which will give us a number which is greater than 1, right? So that ratio multiplied by the pressure inside the fresh water. And we can see clearly the pressure experienced by the fish in the seawater is going to be greater than the pressure experienced by the fish in the fresh water, right? Therefore, even though the two fish in those two different tanks with seawater and fresh water are at the same depth, okay? Because the density of one liquid is greater than that of the other liquid, the one with the greater density will exert more pressure or greater pressure on the fish compared to the other. So in that case, we finally find out that fish A is going to experience the greatest pressure. This is a nice puzzle which depends on fluids. So we study how objects experience pressure in fluids, and we know that it depends on how deep they are inside the liquid. Okay. All right. So this brings us to the end of today's video. If you are new to this channel or found this helpful, like, share, and subscribe to this channel. If you are already a member, thank you so much. And until then, I will see you in my next video.